Alright guys, here in this video, this is the second example in chapter 3. This is the second example we are solving. We solved the first example in the first video on this chapter 3 when we are talking about torsion. Now this is the second example, and this is another type of example. In chapter 3 we will solve 3 different types of example. In the first video we solved the first type. Here this is the second type, and here we are talking about the shaft. And here we are asked, we know in chapter 3, the first video, I told you there are 3 main important formulas we need. Here we will use the same formulas, and I'm so sure we know, we still remember those formulas, because that is the formulas that we are going to use in this chapter 3, where we say that one of the formula we say is J is equals to pi over 2c to the 4. This is, and the angle of twist we said is TL over kg. Okay. Then finally the third equation we said is maximum shear stress, TC over J. So this is the equations we derived. I told you something about these 3 equations which we derived from the introduction part of this torsion, this chapter 3. So mainly we are going to use these 3 equations, as I've said earlier in first video. Then here in the second video we are giving this this is a combination of like 1, 2, 3, 4 members to make one to make a body. Then we have this shaft. This one is A, B and C. So here they ask to find the maximum shear stress at shaft A and B here. So we are looking for the maximum shear stress within this area, and the B part at B and C. So we're also looking for the maximum shear stress within this area. So when we look at our formula, we know that our maximum shear stress is TC over J. So right now we know here we are told that the diameter of this place is 46 millimeter, and diameter of this place is 30 millimeter. Okay, so what do we do now? Since we are looking for the maximum shear stress of this place, we look at the body. The first thing to do is to put the reaction torsion in this place. I told you in the chapter 2 that before you when you are solving one example, I told you that if you are asked to find something and you are looking for the torsion or the force, the deformation, when I told you that deformation is equals to force, then the force should be force of AB, not just the force. So here we are looking for the torsion, and the torsion we are looking for is T. The torsion here is TAB. Okay, so we will find the torsion TAB, which is within this place. So in that case we will cut this place. Some students, they will like to find this place, find the reaction torsion here, then they will start under. Some students, they don't need it, they will start from the beginning. So let's not put this, let's start from the beginning. So here we know our C we said is diameter over 2, so 30 divided by 2 is 15. We already know this. And J, we are going to find J, which we said that J is pi over 2c to the 4. So let's solve this example. The first thing to do is to cut this place to find the reaction torsion of the member which we are looking for, AB. So let's find TAB. So first at this, if you cut it, here is our solution. When we cut it, we will find something. I cut it somewhere here, so I have something like this. I cut it from here. So I have something like this, where we know that there is a reaction torsion here, and this is TA is equals to 300. Here is A. So I have to replace a reaction torsion here where I cut it, and I will say is TAB. So what is my TAB? Summation of torsion. From here, I will say that summation of torsion, let me use another pen, in this direction, let me say in this direction is negative, in this direction is positive. It's equals to 0. So here, from here, I will say that this torsion is the opposite of this. So let's say this is positive. So TA, which is our 300, minus TAB is equals to 0. So from here, okay, so from here we say that 300 minus TAB is equals to 0. When this crosses, 300 is equals to so when this crosses, TAB is equals to minus 300. Okay, so here just know that even if you don't need to solve for this, if this is positive, you have to know that this place should be negative so that it will be in equilibrium, so that the member will be statically in equilibrium. So here we found this as, since this place is 300, this T here, TAB here, should be minus 300. We don't need to solve this even. So now now we have found our TAB. So what do we need? C and J. So let's solve for J. From here, our J is equals to pi over 2 C to the 4. So if we I told you that C is equals to D over 2. So we have our D diameter here, which is 300 divided by 2. So our C here should be 15. So let's say 15 to the cube, to the fourth. Okay, so this is our J. Now let's put it here to find our maximum shear stress. So we say our maximum shear stress from here maximum shear stress at AB is T at AB. I take the formula T at AB multiplied by C over J. So from here, my TAB is minus 300. Remember what I told you earlier? When you solve for when you are solving for torsion, we don't consider negative and positive sign. We don't consider it. So let's say this is 300. 300. Then our this thing unit here is Newton meter. So we have to multiply it by 1000 to have Newton millimeter. We need one meter here, so we have to multiply it by 1000 to have Newton millimeter. So yeah, if you multiply it by 1000, we have this Newton millimeter. Okay, times C. Our C we know is 15 millimeter. So if you don't like, if you like, you can multiply it. If you don't like, you leave it like that. Remember, you make sure it will balance. So if you leave it like this, that means this one will be because this is a millimeter. It's a millimeter. So if you leave it like that, you will come here and say divide by 1000, so that you will remove 1 millimeter. But this is millimeter, which means we will multiply it by 1000 to balance it. So what will be our J? We found our J here. Our J is pi over 2 to 15 for millimeter to the fourth. Okay, so what will be our final answer? Let me check. Remember, this millimeter and this millimeter will go here, so we have millimeter to the 2. Okay, so Newton millimeter to the cube, I told you in chapter 1 that Newton millimeter to the cube is megapascal. So this, we will have our final answer 56.6. From here, our final answer megapascal. Okay, so here, this is the shear stress in this shaft. This is the shear stress in this shaft. Let me try to explain to you what this shaft is all about. This shaft is like this, and this one is like this, and the torque here is applying in the other direction. So let me shift it this way and bring it up here. So what we are saying is this is like this, then we apply torque in this direction. So if you are applying it like this, it's going round like this, what will be the maximum shear stress, so that at a point the thing will deform to have a cut. So so that is what we find, that the maximum shear stress is 56.6. So after you get 56.6, this member here will cut off, like we've shown it here. So that is it. Then we have found the maximum shear stress at shaft A, B. You have to do the same at shaft A, B, and C, so that it will cut here. So what do? You need J and you need C. Our C here in this part, our C here is equals to 46 over 2, which is 23 millimeter. Okay, here, which is 23 millimeter. Then we come and say that our maximum shear stress at point BC, we are looking for BC, BC. So here is the same formula, T at BC multiplied by T all over J. So from here, what is our T? What is our TBC? Now you have to add this place. We are looking for this place. Our TBC is 300 plus 400 is 700. Okay, for 700. Then negative. So we will have the TBC as a positive 700. Okay, remember what I did here? I cut something. I cut it here. Then I have only one torsion force. I replace the down one so that it will be equilibrium. Okay, so the negative sign of that same one. So if you cut this place, you will find out that your member will be something like this. It will be something like this. Then it is cut from here. So if this place is 300 and this place is 400, then what is this place? This addition of these two, 4, 7 should be 700. Okay, so when this 2 is going, this 2 will correspond with this 2. So we say that force at BC is 700. Remember what we did here? We have our C in millimeter. So you have to multiply by 1000 to have our T also with this. So our 700 multiplied by 1000 in Newton millimeter multiplied by what is our C? We found our C as 23 millimeter divided by what is our J? J is pi over 2, 23 to the 4th millimeter to the 4th. Okay, so remember, if you this millimeter 1 will go here, another millimeter will go here, so we have millimeter to the 2, and millimeter to the 2 over Newton is megapascal. So we will find our answer as let me check. It is giving us that 6.6 megapascal. So if the if the rotation you will rotate here, if it exceeds this 36.6, this member here will cut off, it will break. So this is another type. So now we have our maximum shear stress and these two, a shaft BC and AB, which is what we are asked to find. So this is another type of example in this chapter 3. We still use, but here we only use this formula, and this did not come in place. So sometimes they will ask you the question, putting it like this, then the thing will be like it will be vertical like this. It will be vertical like this. So you solve it vertically, but here it's like this. We solve it horizontally. So this is another type of example. So in the next video, I will try to solve another different type of example in this chapter 3, and that will be our last example. So try to look into the 3 types of example we've solved so far in this chapter 3, so that you can be able to analyze it. And also in that same example, we will use this same formula. This formula is very, very important for us in this chapter 3. So that is it. This is all about torsion. So try to analyze this yourself. It's very, very simple. If you know the formula and you can be able to find your T, your torsion, you can be able to solve this. This chapter will be very, very easy for you. So thank you very much. Next video I will solve the last type of example in this chapter 3. So see you in the next video. Try to watch it so you can be able to understand. Thank you.